if we look at area of parallelograms and triangles, they're related to the areas of rectangles with a few modifications. So if we look at these formulas that we have here, all right, and we're looking on this side now, our parallelograms, a lot of times they'll give you B and they'll also give you A, which is the side length here, but this isn't a rectangle, so you can't multiply this by that. It would not be accurate. It would give you something entirely different. So what we do actually is we multiply the base, which is the long way, times this thing called a height, or sometimes you'll see it called an altitude, but for our purposes we're calling it a height. That's what that H stands for. All right, and the height is a perpendicular run up from the base that goes to its parallel side. Okay, and then that forms a height, and because it forms a height, we can use that. And the reason that works is because if you drop this down here, and you think about this, well, if I chop this up and I just move this over here, you would have a rectangle, right? And that rectangle would still be this full base times this height. And so that's why this works. So with triangles, it's a little different. I think the best way to think about a triangle is if you have a triangle, think about like what it would be, right? If you're trying to find a triangle, think about what it would be like if you could make that triangle into a rectangle, right? So if I took this and I make this into a full rectangle, right? And then this part here is half of this, and then this part here is half of this whole thing right here. So this is half of this whole thing. And so what happens is you basically, if you could find the area of that rectangle, you would just take half of it. And so that's why you've got that 1/2 in your formula with the triangle. So it's 1/2 times your base and then your height. And your height would wind up being what your side length would be if you did draw this into a rectangle. All right, so 1/2 base times height for triangle, base times height for parallelogram. So let's do a few problems. This is a parallelogram, all right, and we know that we have the area is base times height. So we just got to make sure we pick the right things here. They're giving us 3 things, all right, and we only need 2. Well, the base is the one that your height is making a right angle with. And this is my height because it's inside here and they're showing it going from one side to the other. So my height's 15 and the base then would have to be this because that's where it's making the right angle with. So it's 8 times 15. 8 times 15 is 120, and then it would be meters squared because it's 8 meters times 15 meters, and then you get meter times meter, which gives you meter squared. All right, triangle with a base 12 millimeters and a height 11 meters. So this could look a bunch of different ways. It could look like this, right? That could be my triangle. My triangle could also look like this, where that's my height. Could look a bunch of different ways. So it's not so important how that looks. The area is 1/2 of the base times height. So it's 1/2. My base is 12 and my height is 11. I always do the 1/2 part first, and if you have an even number as one of your 2 other numbers, then you can just kind of split it up. So half of 12 is 6, so you have 6 times 11, which is 66. And then it would be millimeters squared. All right, and that's kind of what these problems look like. All right, I expect you guys to fully be able to do these, and if you need help with it, feel free to ask whoever it is you're working with, and I'm sure they'll be glad to do that. So good luck.